Day2-Track2-Shreeraj Shah. So what you are doing in this scenario is you are from a laptop, you are logging on to your trading application, passing on the login request, and you get authenticated and you get a cookie back from the server. Next, what you are doing is, since this is a 2.0 kind of application, you are sending an XML request. You are sending an XML request for buy, that I want to buy 20 stocks of Microsoft. So since you have already authenticated, you have a cookie in your place, that request will go and application will identify who you are and place an order for you, and you have a buy request is placed now. Now what you are doing is you are still on, your session is live on that, and you are going to attacker site where you are browsing around and you get a CSRF page load coming to your site on your browser. That will, without your knowledge or without your intention or inclination, that will force a browser to send XML string. This is not a typical name value pair. It is XML string which will get injected into application, and application on behalf of you, 25 stocks of a Google has been placed now. You have no idea what have happened, and all over 2.0 and XML stream. So over here is the payload. Over here what we have is a form. You have a hidden field. Now what we have done over here is a name value pair. In a name I have injected one half of a XML block, which is less than question mark XML version, and the rest of the part of my envelope which I have placed in a 1.0 into the value. Now, and then I have a document.by submit button. So as soon as this page get loaded in my browser without any knowledge of this particular guy or without any click from this guy, what is going to happen is this particular form will get executed and a legitimate XML envelope will be created. And as a post request construct an XML construct any HTTP request, what it's going to do is it will take a name, it will take a value and put equal to in between. So as soon as it put equal to in between, the XML document will look like less than question mark XML version equal to, that's coming from the post 1.0, and then that's a full legitimate XML envelope which is going back and forth. So this is like a JSON, or this is like a XML called a one-way CSRF. So over here, let me quickly show the demo for this. You have, okay, over here this is a page. You are on a mytrade.com, and John is logging into the application. His user is authenticated and everything looks good at this point to John. He go ahead and place an order now for Microsoft 25, place a buy order over here. And what you have is, this is a response which you get, which is XML over here, which is saying order is placed, and that same response you can see over here as well. And if you look at the request, again this is XML request. This is not like a name value pair where John has placed like a quantity equal to 25, ampersand type equal to MSFT or such. And then everything looks fine and his order has been placed. Now he is going to a site called mytrade2.com. This is not the same domain. This is a different domain where he is now. And just to show, I placed this visit link. It's not required. It can just dynamically load it on the same page, and this attack vector will work. So as soon as he clicks this link, you can see one request generated over here. Now this request is going to mytrade.com where he's already logged in, and he has the XML envelope as you can see over here. XML version equal to 1.0. So without his knowledge, this order has been placed for 20 value of Google stocks, and he has no idea about it. So this is essentially a CSRF, cross-site request forgery, one way, where you are just forcing the browser to go out. Now there is a mutation to it as well. Say for example you are using the JSON instead of XML, or a JS object or a JS array. Then what attacker can do is it can open a two-way channel. So over here now what we have is, browser will, as soon as you go to this attacker site, it will load the payload into your site, and that will go out, force a request from your browser to go to a target site, fetch the request, fetch the response in a JS array or a JS object, and whatever value you have will send back to your mothership, or where your listener is running with. So over here, say for example your banking application is giving a profile.aspx in a JS array. So this is a JavaScript array where your profile is coming to your browser. So over here what I can do, or someone can do, is doing a function overloading of array. So as soon as I have my page where it is not using the function of the array of your browser, but it is using your my function, which is already a part of the array, so it's get overloaded. And as soon as your array come to me, this function is going to be get loaded, and all your value from the array will get stolen and sent to the target site. So over here, say for example, we go to this quickly, a demo. I don't have much time now. But over here, this is what I'm getting back when I do a profile.aspx. So now as soon as I go to the mytrade2.com, you can see what have happened is 4 requests which are generated, all the account value, John Smith and such, and sent back to mytrade2.com. Over here is a collect.aspx page, here is my array overload, and here is a script src tag which will not follow the SOP and force your browser to send a request to a target page. So this is another new vector, or kind of a new vector which will run against just the JSON or a JS array or object. Then you have RSS manipulation. Your script, you are getting a RSS feed coming from your various different untrusted sources. So if your RSS application is vulnerable on 2.0 application, so here I have some widgets where different widgets are there for a calendar and weather and such, and then there is a little RSS feed widget. So you click the trade news. So over here, as you can see, the request is going for proxy.aspx and then going to RSS news. You continue that, and here is what response you get. Now this response is XML response, which is RSS feed, a legitimate RSS feed which is coming to your browser, and application is just loading it without validating. And as soon as you click this, it's the cross-site scripting, and someone has injected a script in your feed over here. Here is your link. So any payload, any iframe, anything can be injected over here. It is a very simple alert which we are injecting, but anything can be injected over here. So this is another vector which is RSS manipulation. Then you have RSS feed. Another is a reverse engineering and a logical hacks. What you can do is essentially you can download the full Flash component, you can download all the JavaScript and reverse engineer. There is a debugger out there which you can use to debug JavaScript and try to reverse engineer the logic. Now with a 1.0 and a 2.0, the cardinal difference is that a lot of business logic has shifted to a client side. So in previous components, all these business logic used to run on the server. Now you can see this business logic bits and pieces in your client side. So 2 or 3 applications where we have analyzed where access control was little part of this script, where you can manipulate values and try to hack into the system and try to bypass authorization on the logical hacks. And finally, you can do a WSDL enumeration and exposure. WSDL is essentially what you are looking at is your web services definition language, where if you are running with the web services at the end, then there is a WSDL, and if it's opening a function which are not a private, which you don't want to expose, then you can have an attacker can enumerate this WSDL file and identify possible hacks. So say for example over here, you are running with the enumeration with the WSDL. So here is your page where you have access point where you have a full WSDL file, and what you can do is you can download this WS scanner, point your web services to WS scanner, and you can see all the functions over here. Now what we have seen is like many times developers, when you analyze these functions, you can identify certain functions which are admin function, certain function which if you brute force these functions, you can get the internal privileges of the application. So then you can go ahead and start the listener over here on the port, and this is the SOAP traffic which is going, and you start playing around with all these different fields like we used to do with the name value pair, and try to see what you are getting out from the application or assessment of this particular application. And then if you want to do further assessment, you can do SQL injection over here on the SOAP envelopes. So all these different SOAP envelope where you can do the injections over here. So you can do 1 or 1 equal to 1 over SOAP and such. So this is what can happen. This is all over a SOAP injection. You can do a fuzzing if you want to do a fuzz of the SOAP request. WS scanner has something called WS fuzzer. So what you do, you define target, you define a fuzz load, you define your regular expression, what you are looking at, and then over here I'm looking for a 500 and fault code, because fault code is like a 500 error for your application. So when a SOAP fails, it gives you a fault code instead of a typical message. So I'm looking for all this and this, and then I start fuzzing. So I write a hash fuzz hash where I want to do a fuzzing, and I leave it, start the fuzzer, and I can start enumerating all these errors. You can see these red stuff where all these errors are the fault code which are possible to exploit further. Now I've identified the points which are vulnerable in your SOA or a SOAP or a service oriented architecture and such. So all this is essentially next attack vector, which is a SOAP and other service injection which you are doing. Once you have a web services, you start doing injection into it. Identify or discover injection point, and everything else is the same. Whatever you are doing for your traditional application, SQL injection, LDAP, XPath, whatever you are doing after that is the same. And finally, the widgets and gadgets hacking. Few of the gadgets and widgets frameworks which we have evaluated in the past. What we have seen is like when your gadgets and widgets are running on the same DOM, then one of the gadgets, if you have a JavaScript for that gadget, that little gadget can actually monitor your entire DOM. So then if you have a Gmail gadget over here and your malicious gadget sitting over here, and you enter your username and password in that Gmail gadget, this gadget can see what you are doing on the part of the DOM. This happens when you are using the same DOM. So what we are seeing is, like, say for example, if you go to the Google or IG page or such, what they are doing is every gadget will get loaded in their separate iframes. So then where they are separate, running on the separate iframe, what is going to happen is that iframe's DOM will be restricted to that particular DOM only. You won't be able to access DOM from the same DOM. So that's different kind of a, when we are looking at the widgets, gadgets and module architecture, these are some of the checks which we make and try to identify what kind of a vulnerability can be running on this. And then finally, for the countermeasures and security, scanning the code base, identifying linkages, method signature, all these different things which you need to do for the 2.0 perspective now. And in 2.0 application, it is if you have the source code, it's a probability of identifying vulnerability is high compared to a black box testing, because a lot of things are hidden and hidden calls are going on. And second, you need to do a content filtering. If you are using the application layer firewall, it's a name value pair firewall will not work. You need to do a SOAP or a JSON based traffic analysis and ISAP level filtering to identify XML blocks and XML tags and such. So this is all about the content filtering and such. So these are the top 10 attack vectors which we are seeing popular. Once you have vulnerability, then there is a whole range of exploitation which you can do a one-way attack, or you can upload files and whatnot. Several things which you can do, and all these will happen over a JSON pipe or XML pipe or such, like used to happen on a traditional way. So in conclusion, Web 2.0 bringing new challenges for the folks who are doing assessment and audits. It is also challenging for who are developing the application, needs to adopt new methodologies for scanning. Attacks and entry points are scattered in multiple. HX and SOA are key components which we are seeing. WEF and a code review are important aspect for Web 2.0 defense, like a traditional defense. So that's pretty much what I wanted to cover. Any questions on this? I have some time for questions. Yeah, like 1 or 2 minutes. So like any question? A question? Yeah, please.
I didn't quite understand with the XSRF attack with the XML envelope.
Okay, I can very quickly show you.
Yeah, the same domain policy. I didn't quite understand why that didn't kick in.
What I'm doing over here is, it's an interesting question. When I was looking at one of the clients where I'm working was, they were using this XML envelope back and forth for the analysis. So I wanted to do XML based CSRF. So I want to get a typical HTML form loaded, which will initiate an XML request to my target application, right? So definitely you can put a SRC tag and put if it is a name value pair, it's a very common. You just put ID equal to 1. Now how you can do the same thing with XML. So you have to have a post request, and in your post request